Over 2 days in February 1974, Balick and Brown observed the galactic center at a high enough resolution to see a discrete, intense source of radio waves. That was the first time humans had gotten a sighting of what would later be called black holes and wondered what lies within them. Hello and welcome to the channel. We are going to try and decipher what lies inside the black hole and whether it has possibly a universe residing within. This and more in today's video. Is it possible that the entire universe is within a black hole? Most experts will tell you that the universe started as an infinitely hot and dense point called a singularity. If you are wondering, then take a minute and think, because that is what the same experts call black holes. It is, in fact, and some physicists say they could be the same. The singularity in every black hole might give birth to a baby universe. There is no reason to think our universe is any different. Full of curiosities, black holes form when a very massive star dies and its core collapses into a space so small that not even light can escape it. The boundary that defines the point of no return is called the event horizon, and a sort of opaque wrapping that doesn't let you see the singularity itself. Importantly, as matter falls into the black hole, the event horizon grows rapidly at first as the black hole begins to form, then more slowly as matter falls in at a lower rate. During the first trillionth of a second after the Big Bang, the universe has long drawn out incredibly rapidly faster than the speed of light. Since space was technically being created, that universal speed limit didn't have much sway. Over time, that expansion slowed down. Doesn't that sound a lot like a black hole's event horizon? Is it possible that our universe is the event horizon in some other universe's black hole? One of the best known examples of an event horizon derives from general relativity's description of a black hole, a celestial object so dense that no nearby matter or radiation can escape its gravitational field. Often, this is described as the boundary within which the black hole's escape velocity is greater than the speed of light. However, a more detailed description is that within this horizon, all light-like paths that light could take, and hence all paths in the forward light cones of particles within the horizon, is warped to fall farther into the hole. Once a particle is inside the horizon, moving into the hole is as inevitable as moving forward in time, no matter in what direction the particle is traveling, and can be thought of as equivalent to doing so, depending on the space-time coordinate system used. The surface at the Schwarzschild radius acts as an event horizon in a non-rotating body that fits inside this radius, although a rotating black hole operates slightly differently. The Schwarzschild radius of an object is proportional to its mass. Theoretically, any amount of matter will become a black hole if compressed into a space that fits within its corresponding Schwarzschild radius. For the mass of the Sun, this radius is approximately 3 kilometers or 1.9 miles. For Earth, it is about 9 millimeters or 0.35 inches. In practice, however, neither Earth nor the Sun has the necessary mass and therefore the necessary gravitational force to overcome electron and neutron degeneracy pressure. The minimal mass required for a star to collapse beyond these pressures is the Tolman-Oppenheimer-Volkoff limit, which is approximately 3 solar masses. All the way down. 3-dimensional black holes in our universe have 2-dimensional event horizons. That means for our universe to be an event horizon, it had to have been born out of a 4-dimensional black hole in a 4-dimensional universe. Sounds crazy, right? We can't calculate what happens in a black hole singularity. The laws of physics break down, but we can calculate what happens on the boundary of an event horizon. As matter falls into the black hole, the event horizon encodes that information. The black hole and the event horizon grow in tandem so that the surface area is the exact right size to contain the information for all of the matter that has ever fallen in since the black hole's inception. All that information could translate to everything that exists in our universe. And believe it or not, the math adds up and solves some long-stewing issues in the process. So say researchers at the Perimeter Institute and the University of Waterloo, who first posed this possibility back in 2014. One big problem with the Big Bang, according to the Perimeter Institute, is that the Big Bang hypothesis has our relatively comprehensible, uniform, and predictable universe arising from the physics-destroying insanity of a singularity. It seems unlikely. The black hole hypothesis is a lot cleaner, if mind-bendingly hard to picture. We might live in a universe within a black hole, within a universe within a black hole. It might just be black holes down. Air pressure is 90 times greater than on Earth. Temperatures are hot enough to melt lead. An atmosphere composed of toxic carbon dioxide and sulfuric acid. In other words, hell. And yet billions of years ago, things were different. Venus did resemble a sister of our planet. Liquid water oceans, white fluffy clouds, a place for life to potentially call home, and now, like I said, dead. What did it do? The conventional story goes like this. Billions of years ago, our sun was smaller and dimmer, and Venus was perfectly fine, chilling out. But as the sun aged, it got brighter and hotter. Venus started to sweat. The oceans began to evaporate. The increased water vapor in the air trapped more heat. The oceans dried up. With no more oceans to lubricate the gears, tectonic activity and the great shifting of continental plates shut down. Carbon that would normally get recycled and buried deep within the planet was instead vented into the atmosphere, skyrocketing the temperatures and choking off any possibility for life. All this happened long ago when life on Earth was nothing more than simple, microscopic one-cell critters wiggling around in the ocean. Matt Mons is displayed in this three-dimensional perspective view of the surface of Venus. Magellan. But new research suggests Venus didn't die billions of years ago. Its oceans may have survived until relatively recently, up to a mere 700 million years ago, which is basically yesterday when it comes to astronomy. The researchers use state-of-the-art computer simulations, the same kinds of simulations used to predict the effects of climate change on the Earth, to see how a brightening sun would scorch Venus. And what they found is that the relationship between Venus and the sun was complicated. It turns out that many little details had big impacts on the survivability of Venus oceans and hence the survivability of any potential life that may have developed over there. In some cases, all the water dried up right away, but in many cases, the presence of large oceans was able to absorb the impact of the hotter sun, keeping everything in the chill zone for a couple of billion years until it couldn't. Something especially bad happened to Venus about 700 million years ago. The phrase used around the polite company is global resurfacing event, but a more accurate phrase would be Venusian Armageddon. In a series of calamities, the surface of Venus managed to flip itself inside out, releasing an unholy amount of buried carbon dioxide into the atmosphere, where it stayed and trapped heat, dealing the final death blow to the doomed planet. We don't know how long it lasted. We don't know if it was one single disaster or a series of unfortunate events. All we know is that this catastrophe happened. And while for decades we have thought that at this point Venus was already long dead, the new research suggests that water and life may have been clinging to existence and perhaps even thriving before this final coup de grace. Could our sister planet have hosted life of any form? Did that life have the time and opportunity to evolve into more complex organisms? Did they reach the capability to watch and understand as the world turned inside out? Venus holds many secrets beneath its cruel atmosphere, and for now, she's not telling. Torsion could also explain the observed imbalance between matter and antimatter in the universe. Because of torsion, the matter would decay into familiar electrons and quarks, and antimatter would decay into dark matter, a mysterious, invisible form of matter that appears to account for a majority of matter in the universe. Torsion, therefore, provides a theoretical foundation for a scenario in which the interior of every black hole becomes a new universe. It also appears as a remedy to several major problems of the current theory of gravity and cosmology. Physicists still need to combine the Einstein-Cardan-Siama-Kibble theory fully with quantum mechanics into a quantum theory of gravity. While resolving some major questions, it raises new ones of its own. For example, what do we know about the parent universe and the black hole inside which our universe resides? How many layers of parent universes would we have? How can we test that our universe lives in a black hole? The last question that can potentially be investigated is, since all stars and thus black holes rotate, our universe would have inherited the parent black hole's axis of rotation as a preferred direction. There is